Alright, so let's pull back from this a little bit and consider just like taking a real number, raising it to a complex power. Right. So set that aside. So now we're going to take a real number raised to a complex power. And you can't see that. Right. Real number to a complex power. Okay. So say we've got something like, I like 2 and 3 because they're nice and small and they're different numbers from each other. So whenever you see a 2, you know which 2 it is, and whenever you see a 3, you know which 3 it is. Right? So 2 to the 3i. That's going to turn out to be the same as e to the 3i times the natural logarithm of 2. And there's a reason that this makes sense, because e to the natural logarithm of 2 is just going to be 2, and then we're raising that to 3i. So this is kind of like take something divided by itself so that you're just multiplying by 1. It's just kind of like a magic trick, right? That helps us out. So this doesn't really explain jack shit, right? But if we look a little bit closer, what we're going to get, actually, let's see, I prefer, I don't know why I wrote it out that way. It's really like that 3 ln 2 is going to become like a component. So it's really more like this, with this being a removable block, right? So that's going to equal, you're going to have the real component, which is the cosine of this thing, 3 natural log of 2, and the imaginary component, sine 3 natural log of 2i. Okay, so now the e is coming into play because of something nice that it does. If you have e as your base, then the angles that you end up with, that you're talking about, are in radians. So these are in radians, and it's just really nice to handle. But we can do a little bit of magic real easily to put it into any unit that we want. We can easily get this into degrees. And what's going to happen is this natural log component is the part that allows us to manipulate that, right? So real quick, what are logarithms? Just in case, just as a brush up. Okay, these are the inverse of exponents, right? So say you've got something like 2 to the third is 8, okay? How do we invert this? So these are the two things that we're putting together, and this is the answer that we're getting out. What logarithms do is it'll take these two things and produce the power as the answer, right? So base times power gives you this, but the result and the base, in terms of when using logarithms, those are your inputs, and the exponent is your output. Okay, so this turns into, and they go back and forth, right? Because they're inverses of each other. 3 is the log base 2 of 8. So one way you can read this is 3 is the exponent of 2 that yields 8. Right? When we have 2 with an exponent of 3, we get 8 out. 3 is the exponent on 2 that gives 8. Very simple. Okay. So now back to this guy. What's happening here? ln is the log base e. ln is a lot shorter to write than log base e, so just write ln. Kind of nice. I don't have any problems with that. That's lovely. So what we want to do is we want to, say we want to work in degrees, right? So we want to take, first off, this 3 here is that part of the exponent is causing us to wrap around the circle faster and faster and faster, or more and more and more. So if we make that a 1, then it'll just go the amount, the number of degrees or radians or whatever the hell we're talking about, 1 time. Right. So if this is just I, then this would just be a 1 right here, and this would just give us radians. Or with our conversion factor, degrees or whatever the hell else you want. Okay, so what this is at something like this, e to the pi I, we're going pi radians around, and so that gives us a -1. Okay, what we want is some number where when we go 180 around, we also get -1. All right, we want something that looks very similar to this, but it operates this way. All right. This is easy to do. This is easy to do. So we can play with this, right? So this 180 is like the 3. So we're going to get, right, if we look at this, so x is 180 I. That's the same as e to the 180 I times ln of x. And that will give us these components here. Cosine 180 ln of x plus sine 180 ln of x I. Now, this has all got to equal -1. Okay? So this angle has to be pi radians. So ln of x has to be pi over 180. So x has to be e to the pi over 180. So now, very easily, you can just change your units to whatever you want. If you want to use degrees, you can do this.